Imagine stepping onto a battlefield where your greatest weapon isn't a rifle, but the fact that the enemy's most advanced sensors just look right through you. I mean, I want you to really picture this scenario for a second. You are out there in the dark, and it's not just your visual outline that is missing. Your body heat is totally gone. The physical vibrations of your footsteps are gone.
Right.
Even your digital footprint has literally vanished into thin air. You are essentially a ghost walking through a world that has spent the last 50 years designing sensors to detect absolutely everything.
Yeah. And when you look at the trajectory of modern combat over, well, really the last 2 decades, being seen has essentially become synonymous with being targeted.
Mm.
I mean, the absolute moment a biological or mechanical entity registers on an adversary's sensor network, a kinetic strike is already being calculated.
Okay.
So surviving in that environment requires just a total paradigm shift.
And that shift is exactly what we are exploring today. So the mission for this deep dive into the source material is unpacking a stack of utterly fascinating, heavily detailed 2026 documents and technical schematics.
Oh, they are incredible documents.
They really are. And they detail something called the Ghost Soldier Program. And let me set the stakes for you right up front, because this is not science fiction, and it's not some concept for 100 years from now. This is the projected future of infantry stealth, slated for deployment between 2026 and 2035. And it is all built around a revolutionary smart skin called PhantomWeave.
Yeah, and to understand the sheer scale of what these documents are proposing, we really have to look at the foundational history of military doctrine. Because for centuries, I mean, warfare has relied on passive protection. You put thick steel armor on a tank to stop a shell, or, you print standard camouflage patterns on a uniform, hoping to blend in with the foliage.
Right, you're just putting a passive barrier between yourself and the enemy.
Exactly, but this program abandons that entirely in favor of active signature management. The goal, and is undeniably one of the most ambitious engineering challenges ever attempted, is to give a single foot soldier the stealth capabilities of a fifth-generation fighter jet.
Okay, let's unpack this, because if you want to make a human being completely invisible to a modern drone, you can't just, paint their clothes the color of the dirt. You have to start with the most glaring, immediate problem, which is the biological furnace operating inside the suit. I mean, you can't be invisible if you are glowing like a neon beacon on an infrared camera.
No, you absolutely cannot. And the physics of human biology make us incredibly vulnerable to thermal imaging. A standard fabric uniform, whether it's cotton nylon or even modern combat blends, does essentially nothing to mask the localized heat concentrations of a mammalian body. We just do not emit heat evenly.
Right. We're not just uniformly warm all over.
Far from it. The heat pools in specific, highly vascularized zones. So the cranium, the armpits, the femoral arteries running down the inner thighs, these are massive thermal liabilities. To a modern infrared sensor, a human in the woods isn't just a warm shape. They are a cluster of intensely bright hotspots.
So, looking at the documents, they indicate that the first major technological leap in the PhantomWeave suit tackles this exact vulnerability using something called CVD graphene. And the specs here claim it has an extreme thermal conductivity of about 5,000 watts per meter Kelvin. Which, that number sounds huge, but let's ground that for a second. If I'm wearing this material, how does that conductivity actually hide my femoral artery from a thermal scope?
Well, think about the physics of a heat pipe, or even more simply, how a high-end copper pan functions in your kitchen. If you put a thin, cheap steel pan on a stove burner, the heat just stays right over the flame, right?
Yeah.
You get a blazing hot spot in the middle and the edges stay cool.
Yeah, and you burn your food in the center.
Exactly. But copper is highly thermally conductive. It pulls that concentrated heat outward, distributing it uniformly across the entire surface.
Oh, I see. So it flattens the temperature out.
Precisely. The PhantomWeave acts as a lateral heat spreader. By utilizing CVD, which stands for chemical vapor deposition graphene, engineers are actually able to grow sheets of carbon atoms that are perfectly structured to move thermal energy laterally. It whisks the metabolic heat away from those critical hotspots and forces it to distribute evenly across the entire surface area of the uniform.
So it's basically taking the heat from your armpits and spreading it all the way down to your shins and out to your fingertips.
That's it exactly. And by flattening the thermal topography of the human body, the suit drops the peak infrared contrast by an astounding 70 to 90%.
Wait, up to 90%. So if a drone camera is sweeping a tree line, instead of seeing the distinct, bright thermal outline of a human head and torso, what does it see? It just sees a faint, heavily diffused blur.
A blur that doesn't trigger the software's shape recognition algorithms.
Yeah.
Yes, That is the intended outcome. But you have to consider the thermodynamic trap here. If you are constantly pulling heat away from the body and
Huh?
trapping it in the suit to spread it around, well, the entire surface of the uniform will inevitably begin to heat up.
Oh, right. Because the heat has to go somewhere.
Right. It might be a uniform blur, but eventually it will be a glowing hot blur. You absolutely have to expel that thermal energy from the system.
Yeah, because the soldier is still generating heat. I mean, if they're sprinting with 50 pounds of gear, they're a massive heat engine. So where does all that energy actually go? And this brings us to a concept in the schematics that honestly sounds like pure magic to me. The documents call it tuning to the atmospheric window via radiative cooling.
Oh, it is a brilliant exploitation of atmospheric physics. So the Earth's atmosphere is composed of various gases, water vapor, carbon dioxide, ozone, and these absorb different wavelengths of infrared light. That is fundamentally how the greenhouse effect works.
Right, they trap the heat in.
Exactly. However, there is a specific range of wavelengths, specifically between 8 and 13 micrometers, where the atmosphere is almost entirely transparent. It basically doesn't absorb radiation in that band at all. It just lets it pass completely unimpeded.
So it's literally a window straight out into the cosmos.
Precisely. The outer layer of the PhantomWeave is structurally engineered to emit its trapped thermal energy specifically within that 8 to 13 micrometer wavelength. And because the atmosphere cannot trap this specific frequency of heat, the metabolic energy of the soldier radiates directly through the sky and into the deep freeze of outer space.
That is just wild. But hold on, I have to push back on that a little bit. I mean, venting into space makes perfect sense if I am standing in an open desert under a perfectly clear night sky. But warfare doesn't just happen in open fields. What if this ghost soldier is infiltrating a concrete bunker? Or, crawling through the dense undergrowth of a jungle canopy? That 8 to 13 micrometer radiation can't just pass through a concrete roof, right?
No, it can't. And that is a critical operational variable. In environments with heavy overhead obstruction, the radiative cooling effect is severely diminished. The energy hits the canopy or the concrete and bounces back, or it simply heats the immediate surrounding air.
So what happens to the soldier then? Do they just light up on thermal?
Well, in those scenarios, the suit relies on its internal thermal buffering capacity and the sheer efficiency of its lateral spreading to buy the soldier time. It won't keep them invisible indefinitely in a closed, hot room, no, but it significantly degrades the clarity of the thermal signature long enough for them to maneuver. The goal here is to delay detection, not necessarily achieve absolute permanent thermodynamic invisibility.
I mean, even delaying detection by a few minutes in a raid scenario is a massive tactical advantage. But let's assume the thermal problem is managed for a moment. The soldier's heat is flattened, it's vented, they are thermally hidden. If you're standing in broad daylight against a brick wall, hiding your body heat doesn't really matter if you're wearing, like, a woodland camo pattern. Hiding the heat is step one. Step two is visually matching the environment.
And this is where we transition from passive thermal management to active emissivity. Because traditional camouflage is static. It works in the environment it was designed for, and it fails everywhere else. The Ghost Soldier program envisions a uniform that functions as a massive, flexible, electroactive display, capable of altering its physical and thermal appearance on demand.
Yeah, the schematics outline this as a multi-layer thermal stealth sandwich, and I want you to picture the cross-section of this fabric because it's wildly complex. On the absolute exterior, you have a hydrophobic rain protection sheath. It's essentially a ruggedized, waterproof nylon, but it incorporates graphene oxide to manage environmental moisture without compromising the electronics underneath.
Right, which is essential for field durability.
Exactly. Then beneath that, you have the workhorse layer. We're talking anywhere from 5 to 20 atomic layers of graphene film. Then, moving closer to the soldier's skin, there's an insulating spacer and a low emissivity silver graphene hybrid layer to bounce any remaining body heat back inward.
The architecture is incredibly impressive. But the mechanism that actually achieves the camouflage, what the documents refer to as the chameleon effect, is buried right in the middle of those layers. The engineers have essentially sandwiched an ionic electrolyte between the primary graphene layer and a secondary hybrid layer made of MXenes.
Okay, I need to pause you right there because we need a deep chemistry dive here. MXene sounds like a term pulled straight out of a comic book. I had never heard of it before reading this. What exactly is an MXene layer, and how does combining it with an electrolyte turn a fabric into a chameleon?
It is truly cutting-edge material science.
Yeah.
So MXenes are a relatively new class of two-dimensional inorganic compounds. They are composed of layers of transition metal carbides, nitrides, or carbonitrides, and they are incredibly thin, literally just a few atoms thick.
Wow.
Yeah. And what makes them so profoundly valuable here is their exceptional electrical conductivity and their ability to intercalate or temporarily trap ions within their structure.
So they act kind of like a sponge for electrical charges.
That's actually a highly effective way to visualize it. The suit's integrated power system applies microscopic electrical currents. We are talking about an incredibly low voltage, perhaps just 3 to 5 volts, across this electrolyte layer. When that voltage hits, ions from the electrolyte are forced into the crystalline structure of the graphene and MXene layers. And this microscopic physical shift at the atomic level fundamentally alters the material's emissivity coefficient.
And emissivity meaning how effectively a surface radiates its thermal energy.
Correct. By intentionally shifting that coefficient using just a 3-volt charge, the suit can forcefully manipulate how it appears to thermal sensors. It totally decouples the exterior appearance of the suit from the biological reality inside of it.
Let me paint a picture to make sure I'm grasping the tactical application of this. Let's say our soldier is leaning against a sun-baked stone wall in the middle of a July afternoon. But the soldier inside the suit is completely still and their core temperature is steady, maybe even a little cool. The suit detects the blazing heat of the wall behind them, applies that tiny microcurrent to the MXene layer, and artificially raises the emissivity of the exterior fabric to match the exact thermal output of the hot stone.
Yes.
So to a drone's thermal camera, there is no soldier. There is only a continuous hot wall.
That is the exact operational intent. The suit assesses the background thermal data and continuously tunes its exterior to match it. But as you alluded to earlier, thermal invisibility is only half of the camouflage equation. The visual spectrum, what human eyes and standard optical cameras see, is equally critical, especially in daylight operations.
And the mechanism for the visual spectrum is where the suit stops sounding like a piece of clothing and really starts sounding like a living organism. Because the outer layer isn't just a solid sheet of fabric. The schematics show it is composed of thousands of microscopic hexagonal shards, and they operate like biological pixels.
Right, the synthetic chromatophores.
Yeah, the documents specifically mention that these pixels are running context-aware algorithms that mimic cephalopods. I mean, if you've ever watched a nature documentary and seen a cuttlefish hovering over a coral reef, you know exactly what we're talking about. The cuttlefish's skin instantly ripples, and the color and texture physically change to perfectly match the jagged, colorful coral beneath it.
And the cuttlefish utilizes millions of specialized pigment cells called chromatophores to do that, which expand and contract in milliseconds, entirely driven by their nervous system. The Ghost soldier suit replicates this mechanically. The hexagonal shards act as those synthetic chromatophores. Utilizing microcameras and environmental sensors built right into the suit's architecture, the onboard processing unit reads the surrounding visual environment.
So it's looking at the color of the dirt, the dappled shadows of a forest canopy, the geometric grays of an urban street.
Exactly. And it physically adjusts the color and dithered patterns of those hexagonal shards in real time.
So if a soldier is leopard crawling across an open field, the suit is constantly calculating the shifting shadows of the grass and adjusting the pixels on their back to match. It's a breathing, active camouflage. But, all this cloaking tech creates a glaring paradox to me, because stealth is fundamentally about avoiding the fight. If you are invisible, you theoretically don't need heavy, cumbersome body armor, but the reality of combat is chaotic.
Always. It is inherently unpredictable.
Right. So what happens if a soldier trips a conventional wire, or if an artillery shell lands 30 yards away? I mean, if stealth fails, a silk chameleon suit isn't going to stop supersonic shrapnel. How does this system protect a fragile human body without wrapping it in an inch of heavy steel?
That is the perpetual compromise of infantry armor, isn't it? Mobility versus survivability. And this brings us to the third section of the documents, which details kinetic energy management. The Ghost Soldier uniform attempts to resolve this compromise by integrating non-Newtonian graphene STF into the fabric matrix. And STF stands for shear thickening fluid.
Okay, I think most people have encountered a basic non-Newtonian fluid in grade school science class, usually a mixture of cornstarch and water.
Yeah.
If you move your fingers through it slowly, it feels like a thick liquid, but if you punch it, it instantly feels like a solid brick.
That is the precise mechanical principle at work here, just scaled up using advanced nanomaterials. In a standard liquid, the viscosity, or resistance to flow, remains constant regardless of the force applied to it. But in a shear thickening fluid, the viscosity increases dramatically and instantaneously when subjected to sudden shear stress. The fluid integrated into the Ghost Soldier suit is actually impregnated with microscopic graphene nanoplatelets.
So when the soldier is just walking around, crouching, or reaching into a pouch, the sheer stress on the fluid is incredibly low. The graphene nanoplatelets are suspended loosely, allowing the uniform to bend and flex like a comfortable standard-issue jacket.
Yes, the material remains entirely compliant. But the moment a high-velocity projectile, a 7.62 millimeter bullet, or a jagged piece of mortar shrapnel strikes the fabric, the physical reality of the material changes in microseconds. That sudden extreme kinetic stress causes the graphene nanoplatelets to violently jam together. They completely lose their fluid suspension and lock into a rigid, impenetrable crystalline structure. The documents refer to it as forming an instantaneous molecular wall.
Visualizing that transition is just incredible. Let's take the swimming pool analogy for a second. If you slowly push your hand into a pool, the water molecules have time to move out of the way. Your hand slips right in. But if you take a flat palm and slap the surface of the water as hard as you can, it stings immensely. The speed of the impact forces the water to resist. Now, replace your hand with a bullet traveling at 2,000 feet per second and replace the water with a fluid engineered to instantly crystallize upon impact.
It is a phenomenal defense mechanism, it really is. But the true genius lies in what happens to the kinetic energy after the fluid hardens. When a bullet strikes traditional soft body armor, like standard Kevlar, the fabric catches the bullet, but the kinetic energy still pushes inward. This is called back-face deformation. The armor bows inward, striking the soldier's body with immense force.
And back-face deformation is extremely lethal. Even if the bullet doesn't penetrate your skin, the blunt force trauma of the Kevlar slamming into your chest can shatter ribs, collapse lungs, and cause massive, fatal internal bleeding. Stopping the bullet isn't enough. You have to stop the energy.
Exactly. And this is where the locked graphene structure absolutely excels. When the STF crystallizes, the extreme stiffness of the graphene allows the kinetic energy of the impact to be transferred laterally, meaning outward, across the surface area of the suit, at speeds approaching 20,000 meters per second.
Wait, 20,000 meters per second? The energy is moving across the suit faster than the bullet is traveling forward.
Considerably faster, yes. The structural integrity of the locked graphene nanoplatelets conducts the kinetic shock wave outward, dissipating the localized force before the projectile has time to push the fabric inward. According to the schematics, this rapid lateral energy transfer reduces back-face deformation and blunt force trauma by 50% compared to current NIJ ballistic protection standards.
Cutting blunt force trauma in half while wearing a uniform that flexes like a windbreaker. That fundamentally shifts infantry survival rates on a modern battlefield. You're taking high-velocity explosive impacts and literally washing the energy away across the surface of the soldier's body.
It's a lifesaver, quite literally.
But let's look at the bigger picture here. We've established that the soldier is thermally masked, they're visually camouflaged, and dynamically bullet resistant. But warfare is not just about what an enemy can see or shoot. If a drone is tracking the physical vibrations of footsteps on the ground, or, if a thermal sensor detects the residual heat left behind in a footprint, all of that upper body stealth is rendered completely useless.
It is a critical vulnerability. A ghost that leaves footprints is just a target waiting to be triangulated, which forces us to examine the footwear designed for this program, outlined in Section 4. The Phantom Stride boots are arguably the most heavily engineered component of the entire loadout, specifically designed to silence the ground game.
Yeah, looking at the structural diagrams, these are definitely not standard combat boots. The soles integrate graphene aerogel midsoles, an active Peltier cooling layer, and they are powered by high-density sodium-ion energy cells housed right in the ankle collar. Let's start with the aerogel, because I want to understand how a boot can suppress physical seismic vibrations.
Right, so to understand the dampening capability, you have to understand what an aerogel actually is. It is a synthetic, ultralight, highly porous material derived from a gel, but the liquid component of the gel has been entirely replaced with gas. By integrating graphene into an aerogel structure for the boot's midsole, the engineers have created a material that is structurally robust, but incredibly adept at absorbing and scattering physical shock waves.
The schematics describe it as a dynamic cushion paired with a layered carbon fiber insole plate.
Yes. When the soldier's heel strikes the ground, the kinetic energy of that footfall enters the aerogel matrix. Instead of transferring straight through the rubber and into the soil, the energy is diffused throughout the microscopic pores of the aerogel. It actively flattens the seismic spikes generated by walking or running.
Let's talk about the tactical application of that, because ground vibration sensors are a massive problem for modern infantry. If an elite special forces unit is conducting a covert reconnaissance mission deep behind enemy lines, they aren't just hiding from cameras. The perimeter they are infiltrating is likely seeded with microseismic sensors buried in the dirt.
Historically, bypassing a heavily seeded seismic perimeter requires agonizingly slow movement, finding hard rock paths, or just outright avoiding the area. With the Phantom Stride boots absorbing the kinetic transfer, these elite teams can move at a standard patrol pace directly over or past ground vibration sensors without triggering the threshold alarms. The ground simply doesn't feel them walking.
So they are seismically and acoustically invisible. But what about the thermal footprint? You mentioned earlier that humors are massive heat engines. If a soldier is hiking for 6 hours, their feet are going to be radiating intense heat. Every time they step on cold dirt, they're going to leave a warm patch of earth behind. A drone could just look down and follow that trail of glowing footprints like breadcrumbs.
That is where the engineering gets truly aggressive. The boots incorporate an active thermal management layer utilizing the Peltier effect. Now, the Peltier effect occurs when an electrical current is passed across a junction of two different conductive materials, creating a temperature differential. One side gets hot, the other gets cold. It essentially functions as a solid-state active cooling system, completely devoid of moving parts.
Oh, wow. And the diagrams show microperforated graphene mesh panels leading to an internal microfluidic cooling circuit circling the bottom of the foot.
Exactly. The system actively draws the metabolic heat and moisture away from the sole of the soldier's foot. The Peltier layer ensures that the absolute bottom of the boot, the rubber making actual contact with the earth, matches the ambient temperature of the ground perfectly. It thermally decouples the soldier from the environment, ensuring zero residual heat is transferred into the soil. As you said, a drone cannot track a heat print that simply doesn't exist.
The physical advantages listed alongside these stealth capabilities are just staggering, too. Because they are replacing heavy rubber and thick leather with aerogels and carbon fiber, the documents claim a 50% weight reduction compared to standard combat boots. Furthermore, the carbon fiber insole provides a 40% kinetic energy return.
Meaning the boot acts somewhat like a spring, capturing the downward force of the footstep and releasing it to help propel the soldier's leg upward for the next stride.
Right. And because the boot is lighter and actively assisting the walking motion, they project a 45% reduction in overall ankle and leg fatigue over long marches. When you combine seismic invisibility, zero thermal footprints, less weight, and less physical exhaustion, it drastically alters the operational parameters of infantry movement. A squad can march significantly farther, move much faster, and do it all completely undetected.
But, and this is a big but, this massive accumulation of technology creates a severe operational bottleneck. We have discussed active emissivity chameleon suits, dynamic shear thickening armor, microfluidic cooling, and seismic dampening boots. Every single one of these localized systems requires incredibly complex real-time data processing to function. You have dozens of autonomous subsystems that must act in perfect concert in a chaotic environment without failure.
Yeah, you can't just have a smart boot that doesn't talk to the smart jacket. They require a central nervous system. Which brings us to the command hub of the Ghost Soldier program, which is the Phantom Dome helmet. Visually, the design of this helmet is striking. It doesn't look like a standard round Kevlar dome. It has sharp, faceted, angular geometry, highly reminiscent of the chassis of an F-117 Nighthawk stealth bomber.
And that faceted geometry serves the exact same purpose as it does on a stealth aircraft. A perfectly round object reflects radar and light in all directions, making it highly visible. The sharp angles of the Phantom Dome are specifically engineered to minimize the wearer's radar cross-section, or RCS. More importantly for ground troops, it is designed to deflect LiDAR pulses.
For those who might not know, LiDAR stands for light detection and ranging. It's essentially radar, but it uses rapidly pulsing lasers to measure distances and map 3D environments.
Exactly. Autonomous sentry systems and advanced drones rely heavily on LiDAR to paint and identify targets in complex environments. When a LiDAR laser hits the angular surfaces of the Phantom Dome, the light is deflected away from the source rather than bouncing back to the sensor. The sentry system receives no return signal, rendering the helmet effectively invisible to laser-based targeting.
But protecting the soldier's head from sensors is only half the helmet's job. The internal capabilities are designed to give the soldier absolute situational dominance. The helmet features a waveguide head-up display, or HUD. It utilizes a transparent graphene conductive visor to project a massive amount of tactical data directly into the soldier's field of view without obstructing their natural sight line.
The integration of data streams here is vital. A soldier in combat is perpetually battling the fog of war, the confusion, noise, and lack of clarity inherent to a firefight. The HUD cuts through that by providing 360-degree situational awareness. The documents note the integration of SWAR feeds shortwave infrared, which allows the soldier to see through fog, smoke, and certain types of camouflage that would fool standard night vision.
They also get continuous Blue Force tracking. They can see floating digital markers identifying the exact locations of their squad mates, even through walls or dense jungle foliage. And to manage the chaos of combat audio, the helmet uses integrated bone conduction communication systems paired with noise-canceling sensors for high-decibel acoustic isolation.
Bone conduction technology transmits sound vibrations directly through the bones of the skull to the inner ear, bypassing the eardrum entirely. This means a soldier can wear heavy acoustic protection that entirely blocks the deafening roar of gunfire and explosions, while still receiving crystal-clear radio transmissions from their squad. They can coordinate complex tactical maneuvers silently, without ever vocalizing or compromising their acoustic position.
So you've got a networked ghost, fully aware of their surroundings, completely hidden from sensors. But a ghost still needs to be able to strike. The documents don't just detail the defensive gear, they also outline the arsenal integrated into this stealth ecosystem. Specifically, the graphene combat rifle, the G-Cobra, and its next-generation iteration, the G-Cobra II.
Designing a weapon for this system presents a really unique engineering challenge. What utility is an entirely invisible suit if the moment you pull the trigger, the explosive flash and the searing heat of the rifle barrel instantly give away your position?
That is the classic sniper's dilemma. You take the shot, and the thermal bloom from your barrel announces exactly where you are. The G-Cobra aims to eliminate that entirely. First, the physical construction of the rifle utilizes a monolithic graphene composite frame referred to in the specs as the G2 matrix. This drops the overall weight of the weapon system by a massive 55% compared to legacy rifles.
Which is huge because the reduction in physical weight directly correlates to lethality.
Right.
A lighter weapon means drastically faster target acquisition speeds and significantly reduced upper body fatigue for the operator during prolonged engagements.
But the true innovations are tied to stealth and data integration. The rifle uses electronically ignited caseless ammunition, which eliminates the mechanical noise of a firing pin and the clatter of brass casings hitting the floor. It feeds from a smart magazine that features a built-in lithium graphene power array. But the component that truly fascinated me is the active heat-sinking barrel shroud called the Vortex II.
The thermal management of the weapon barrel mirrors the concepts used in the suit, but applied to far higher temperatures. The Vortex II shroud utilizes integrated graphene microchannels for rapid active and passive thermal dissipation. The thermal energy generated by the friction and expanding gases of the fired projectile is violently wicked away from the metal.
The schematics claim it leaves zero active thermal wake when fired. A soldier could dump an entire magazine downrange in a firefight, and an enemy looking through a thermal scope wouldn't see a glowing hot barrel. The rifle stays perfectly cold.
Furthermore, the weapon ceases to be a separate tool. It becomes a literal extension of the helmet's sensor suite. The G-Cobra features a quantum-secure data link that feeds directly into the Phantom Dome's AR HUD. The rifle has its own integrated multispectral LiDAR and IR targeting suite.
So the soldier doesn't even need to physically raise the rifle to their eye to look down the sights.
No, not at all. The rifle's targeting suite sends the aiming point, ammunition status, and real-time ballistic calculations, compensating for wind, drop, and distance straight to the visor. A soldier could theoretically extend the rifle around a concrete corner, remain completely behind cover, and see exactly what the weapon is aiming at through their HUD, while simultaneously tracking the thermal signature of the target.
It even incorporates a biometric haptic interface trigger that constantly measures the soldier's heart rate and grip pressure, automatically adjusting the trigger pull weight and providing microstabilization cues. The documents estimate this increases first-round accuracy by 35%. The weapon, the suit, and the soldier are effectively operating as a single, synced organism. But let me stop and inject a massive dose of logistical reality into this scenario.
Ah, the power requirements.
Exactly. We are talking about a suit running active liquid armor, electrochemical chameleon pixels, microfluidic boot coolers, an augmented reality supercomputer in a helmet, and a quantum-linked smart rifle. The energy draw for all of this must be astronomical. To power this for a multi-day mission, a soldier would normally need to haul a massive 80-pound backpack filled with lithium-ion bricks, and that completely defeats the purpose of being light, fast, and agile.
You're absolutely right. The reliance on heavy finite batteries has been the primary limiting factor for combat electronics for the past 20 years. It severely restricts infantry mobility and creates a massive, highly vulnerable supply chain. If a unit runs out of batteries in the field, their night vision, radios, and targeting lasers just become dead weight. The Ghost Soldier program approaches this problem from an entirely different angle, which is detailed in Section 6, Kinetic Energy Harvesting.
The concept is that the soldier doesn't carry a battery. The soldier is the battery. The system relies on piezoelectric crystals integrated into the boots and flexible graphene supercapacitors embedded in the high-flex joints of the suit, so the knees, the elbows, the hips. Let's break down the physics here. How does bending a knee power a supercomputer?
It relies on piezoelectricity. Certain materials, including specialized crystals and ceramics, possess a really unique physical property. When you apply mechanical stress to them, when you squeeze them, bend them, or strike them, they generate an electrical charge. The crystalline structure shifts, forcing a separation of positive and negative charges, which actually creates voltage.
So every single time the soldier takes a heavy step, the physical compression of the aerogel sole against the piezoelectric elements generates a tiny pulse of electricity. Every time they flex an elbow to raise their rifle, the mechanical deformation of the graphene supercapacitors in the joint generates power.
Yes. The kinetic energy of human movement is being constantly captured and instantly converted into electrical current. And the efficiency metrics provided in the documents are just remarkable. The engineering models indicate that a soldier marching at a standard patrol pace of 5 kilometers per hour generates sufficient wattage to power the entire active stealth ecosystem indefinitely.
As long as the soldier keeps moving, the chameleon camouflage, the thermal venting, the HUD, the rifle link, it all stays fully powered. There are no charging cables in the field. There are no panicked battery swaps in the middle of a midnight firefight.
And if we extrapolate this outward to the broader military infrastructure, the logistical implications are profound. By eliminating the reliance on traditional chemical batteries, you drastically ease the burden on the supply chain. You no longer need vulnerable convoys delivering pallets of batteries to forward operating bases. And the cost analysis provided in the documents suggests this is not merely a boutique technology for a few elite special operations teams.
Yeah, this is the part that genuinely shocked me. The documents explicitly state a mass production goal of outfitting 1 million troops, 1 million. And the manufacturing process they outline using graphene and MXene inks in a dip-and-spray coating method brings the economy of scale down dramatically. The projected full-issue unit cost target is under $400.
To contextualize that, they're aiming for a 30% cost reduction compared to the legacy OCP fabric uniforms and the standard issue soft body armor currently in use. They're fundamentally proposing delivering 5th-generation sci-fi level stealth capabilities to 1 million infantrymen for less than the retail cost of a commercial smartphone.
But cost isn't the only benefit of this manufacturing method. If you weave an entire suit out of conductive nanomaterials, you inherently create a system with massive fault tolerance. Think about standard wired electronics. If a soldier is wearing a vest with wires running through it to power a radio, and a piece of shrapnel severs that wire, the radio dies. The system fails. What happens to the PhantomWeave if the soldier takes a hit and the fabric tears?
The structural design of PhantomWeave avoids linear wiring entirely. The conductive graphene weave itself functions as the power and data bus. The entire surface area of the uniform is effectively the circuit board. If a bullet or shrapnel tears a hole through the fabric, the system does not fail. The onboard processing instantly recognizes the break in conductivity and dynamically reroutes the data and power streams through the remaining intact lattice of the surrounding fabric.
It essentially heals its own digital pathways instantaneously, and because the entire suit is a continuous conductive mesh wrapping the human body, it inadvertently acts as a highly effective Faraday cage.
Which is crucial. A Faraday cage operates by distributing an external electrical charge around its exterior conductive surface, effectively canceling out the electrical fields within its interior. On a modern battlefield, the threat of electronic warfare, specifically the deployment of electromagnetic pulses, or EMPs, is a constant concern. A localized EMP designed to fry standard, unshielded electronics would instantly disable legacy night vision or radios. But the inherent conductivity of the Ghost Soldier suit blocks those dangerous electromagnetic spikes, ensuring the stealth systems remain online and protecting the soldier's internal biological systems from severe electromagnetic disruption.
Okay, so we explored the physics of hiding the body heat, we've explored surviving kinetic impacts, we've talked about infinite kinetic power. But I want to pivot to the final section of these documents because this is where the Ghost Soldier program stops being a purely defensive hiding tool and transforms into an active, offensive weapon against enemy artificial intelligence. They refer to this capability as the digital glitch.
This represents the most critical conceptual shift in the entire program. We have to acknowledge that on the battlefields of 2026 and beyond, human eyeballs are no longer the primary threat. The deadliest adversaries are autonomous drone swarms and AI-driven sentry systems. These systems utilize highly advanced object recognition software trained on massive datasets of millions of images to instantaneously identify the shape, movement, and thermal profile of a human being in any environment.
We are talking about AI that can spot the specific curve of a human shoulder blade protruding from behind a rock in zero point 0.1 seconds, in pitch blackness, and instantly calculate a filing solution. How does a suit of clothing defeat a neural network that is mathematically designed to find it?
It defeats it by poisoning the data the AI is trying to process. The hexagonal pixel matrix on the exterior of the suit, the synthetic chromatophores we discussed earlier, isn't really matching the colors of a brick wall or a forest floor. It has a secondary protocol capable of generating randomized, highly complex, high-contrast digital noise. The technical term for this is adversarial noise.
I need to understand the mechanics of this. How does projecting digital static crash an AI targeting system?
Well, an AI object recognition system doesn't see the way a human brain sees.
Mm.
It relies on mathematical edge detection, contrast gradients, and predictable geometric patterns to assign a confidence score to an object. Adversarial noise is a carefully calculated pattern of static, often completely imperceptible to the human eye, but glaring to a digital sensor that aggressively breaks up those structural edges. It introduces contradictory data points that confuse the neural network's classification layers.
Oh, it's like throwing a handful of mathematical sand directly into the drone's digital brain. The drone's camera physically captures the image of the soldier, but when the software attempts to categorize that cluster of pixels, the adversarial noise crashes the confidence score. The system literally glitches out, unable to determine if it's looking at a human, a bush, or just a cloud of sensor static.
Exactly. It radically increases the noise-to-signal ratio within the AI's processing matrix. And the most vital metric the documents emphasize here is time. The generation of this adversarial noise delays enemy algorithmic detection by a critical window of 3 to 5 seconds.
3 to 5 seconds might sound completely inconsequential to someone sitting in their living room, but in a close-quarters firefight or when facing an automated turret...
Oh, in modern combat doctrine, 3 to 5 seconds is an absolute eternity. It is the definitive margin between life and death. Modern infantry tactics, and particularly future combat doctrines, are predicated on the concept of first look, first shot. The entity that identifies the target first, engages first, and historically wins the engagement.
So, by forcibly injecting a 5-second processing delay into the enemy's automated targeting loop, the Ghost Soldier system mathematically guarantees that its wearer will possess the first look advantage. The drone pauses, confused by the noise, and in that 5-second window, the networked ghost raises the G-Cobra, uses the AR HUD to acquire the target, and eliminates the threat before the AI even fully registers a human presence. This fundamentally alters the probability of survival in heavily contested environments.
It dictates the tempo of the engagement entirely on the soldier's terms.
Synthesizing this massive journey we've just been on, we started with a fundamental problem, which is hiding a hot, loud human on a sensor-dense battlefield. We've looked at engineering that flattens body heat and vents it into the cosmos. We've explored chemistry that mimics cephalopods to actively blend into walls. We've seen materials science that stops bullets by instantly turning a liquid into a molecular wall. We've examined aerogel boots that silence the massive kinetic shock waves of running while simultaneously freezing the ground to stop thermal tracking.
Oh.
And ultimately, we've seen a digital matrix that literally crashes enemy AI software, all while being infinitely powered by the simple kinetic act of walking.
The overriding takeaway from analyzing these schematics is that the Ghost Soldier program is not an iterative gear upgrade. It is not a slightly better camouflage pattern or a marginally lighter bulletproof vest. It represents a fundamental ground-up reimagining of the human soldier. It strips away the vulnerabilities of a fragile biological target and encases the infantryman in an autonomous, self-powering stealth vehicle. It takes the operational paradigms of a billion-dollar stealth aircraft and seamlessly applies them to a single human being.
It is a profound shift in military capability. And it leaves me with this final, lingering thought for you to consider long after we wrap up today. We've spent the last hour marveling at the genius of this technology, the physics of graphene, the chemistry of MXenes, the sheer incredible survivability it offers a soldier stepping into harm's way. But I want you to think about the macro scale. If this technology is successfully mass-produced, if they hit that 1 million troop mark and this becomes the global standard for infantry, if entire armies are capable of moving completely undetected by thermal optics, by acoustic sensors, by visual cameras, and by advanced AI, what does a war actually look like when neither side can find the other? When the battlefield is completely saturated with invisible ghosts, who takes the first shot?
That is the ultimate defining question of this incoming era of warfare.
We want to thank you for joining us on this deep dive into the source material. It is dense, complex, and heavy material, but it offers a vital, unvarnished glimpse into the immediate future of human conflict. Keep questioning the things you read, keep exploring the science behind the headlines, and we will catch you on the next one.